So good. Let's quickly start with our lesson. So those who are not here, they will get the recording. I'm recording the lesson. So I'll start by answering the questions I gave you yesterday as homework. And then after that, we'll quickly go to the questions we have from the previous question papers. So now, we are required to complete square here in order to find the center of the circle. So let's complete square. So we're going to have x squared plus 4x. So I would like to find out from you, what do you think we're supposed to do in order to complete square on this one? What next are we supposed to do after having 4x there?
And then we're gonna say plus in brackets half times 4 to the power of 2, like close bracket to the power of 2.
Yes.
And then we're gonna minus the same bracket from it. So it's going to be minus half times 4 close bracket to the power of 2.
Yes.
And then plus y squared minus 6y plus, should I say, okay, plus a half, open bracket, a half times 6
And then
minus, so you are freezing, so I'm not sure if it's my network or is it yours.
yeah. What next after having this?
And then it's going to be minus, hello,
Yes, I can hear you. Continue.
it's going to be minus, then open bracket half times 6, then close bracket to the power of 2.
Yes.
And then it will be equal to 37 because we're taking 37 to the right hand side.
Very true. So that is how we're supposed to do this question, to attend to these kind of questions. So, and then the next step is just to simplify this that we have inside the brackets and the square. So we're going to have x squared plus 4x. So that is going to be plus 4 and then minus 4 plus y squared minus 6y. And then there we have 9 minus 9, which is equal to 37. Is that step clear to everybody?
Yes.
All right. So these with negatives, these two values with negatives, we take them to the other side. So it means we're going to have x squared plus 4x plus 4 plus y squared minus 6y plus 9, which will be equal to 37 plus 4 and then plus 9. So then we factorize this. So the factor of that, it will be x plus 2 squared. And the factors of this, it will be y minus 3 squared, of which that will be equal to what? Can you do this for me? I think it's 50, if not mistaken. Is that so?
Yes.
That is 50. So now let's choose the center of the circle from this information here. What will be the center of the circle?
-2
Yes.
and 3.
Yeah. Then now let's proceed and find a radius from this expression. Radius will be equal to what?
So I have a question for the radius.
Yes.
Since in the original equation it's r to the power of 2, right? Does
Yes.
it mean we have to what's this, square root 50 or give 50 to the power of 2?
We have to square root because this 50 is equal to r squared. So r squared is equal to
Okay.
50, right?
Yes.
And then we make r the subject of the formula. How do you think we can make r the subject of the formula from here?
By square rooting it to remove the 2.
Therefore, r will be equal to
5 to the square root of 2.
5 to the square root of 2. But it goes with positive and negative. Né? But after having positive and
Oh,
negative, we will then have to choose the positive one. Why do we choose the positive one? Because r can never be negative. R is a radius which can never be negative, right? So I believe you are all able to calculate the center of the cycle up to this point, of which is a very important step to this analytical geometry. So you must be able to find the center of the cycle on analytical geometry. Let me also clarify the second method that we talked about yesterday, because Dakaro indicated that there's a second method which works for this question. And after we finished the lecture, the extra class, she sent the method to me. Unfortunately or fortunately, the method she was referring to is exactly the same as this method. There's no difference. So what is difference? What is different there is that instead of writing this as half times 4, so we can write this as 4 over 2, of which is exactly the same thing. That is the only difference between the method she was talking about and this method that we have done here. So it's the same. It's complete square, right? So, but I'm happy that you are all able to attend to these questions for complete square. Can we go further other than doing this question for completing square? All right, let's move further. Um, but this time around, I would like to do a question that comes from you. Can you give me a question that requires the application of what we have covered up to so far under analytical geometry? So just go from the previous question and pick the question which you think it challenged you, that requires the application of analytical geometry. So I believe you have question papers with you, right?
yes.
Yeah, so please go and choose a question that requires the application of what we have covered up to so far under analytical geometry. So I will do it with you here on the board. So I'm now waiting for you to send me that question. All right. Let's do this question that I received from Vasitsana. So now, Vasana, tell me, which one do you want us to do there? Is it question number 1 or question number 2?
Question number 2.
All right, so let's do question number 2. So I will send it to the group so that Patu also get the question. So it's question 2. So I will start by drawing a diagram because I will need to explain what is on the diagram here. That is the diagram we are given with an angle alpha down there and H2 and then H1. So now the first question, it requires us to determine the length of AB. I believe you all know that we need to use this distance formula to calculate the length of any distance. So is the length of AB in this case, which the formula for calculating the length of AB is given as x2 minus x1 squared plus y2 minus y1 squared. So in this case, we are given coordinate A, or a point A of -1 is to 3, and B, which is, yes.
Your screen is blurry again.
Oh, okay. Let me check what's the problem. Is it fine now?
Please adjust it again. Yeah, it's fine now.
All right. Yeah, let me know whenever you experience such problems so that I can attend to it. Okay, so then now from there, that will be x1 and that will be y1. So there we're going to have x2 and then y2. So you can name it whichever way you like. You will arrive to the same answer. So now let's calculate AB. So the distance AB in this case, we then have to substitute these two coordinates were given there. So x2, where we have x2, we substitute 4. Where we have x1, we substitute -1. Can any one of you tell me why did I decided to put the brackets there on this value? What was the motive of us having the bracket there?
Your screen is blurry again.
All right. I was explaining here. What's the reason why we need to have the brackets there? So I decided to put small brackets there. What's the main reason for having the small brackets?
It's a negative coordinate.
Yeah, because it's a negative coordinate. Otherwise, if you don't put a bracket here, so you might get this question wrong just because of that simple mistake. So now let's continue. Then now we substitute for y. So if you started by substituting for B, therefore you still have to start by substituting the y value for B there. So it's 1 minus 3 and then square. Vasitana, are we together?
Yes.
All right. And then from there, we can then simplify further. You can use calculator on that step, but if you are smart with mathematics, you can move further, and then this negative it multiplies with -1, it will be +1 squared, and then plus. There we're going to have, at this step, let's just write it as it is. And then on the next step, we're going to have 4 plus 1, which is 5. 5 squared is 25. Plus, then here we have 1 plus 3, which is 4. 4 squared is 16. That will be root of, what is 25 plus 16? Is 35 plus 6, which is 41. Is that so?
Mhm.
Yes. So that is the answer for the first question. So the distance between AB is equal to root of 41. So I believe that first question is clear to all of you, right? Can we go to the second question?
Yes.
Which requires us to calculate the value of alpha. So we need to calculate this value of alpha here. So that value we are going to obtain by using the another formula which I gave you of m, which is equal to tan of theta. In this case, it will be
Tan of alpha.
that will be alpha minus 90 degrees. So, but I think that would be too complex for you. So let me write it as, okay, yeah, that would be fine. So now let's check here. If that angle there is equal to, or it's 180. So let's write it as 180 degrees minus alpha. So let me explain where we are getting that 180 minus alpha. So we want to get this angle here, which is included by this line AB. So in order to get this angle, which is included by the line AC, we need to say 180 degree minus alpha. I believe you all agree with me on that one, right? By using angle on a straight line.
Yes.
So this angle here will be 180 minus alpha. So we are not interested to this angle here. We are interested to that angle there. So it's the one which is equal to tan of, is the one which is equal to m, of which m here is AC. So now, our next task is to calculate the gradient of AC. So let's calculate the gradient of AC. So the gradient of AC is given by y2 minus y1 divided by x2 minus x1. And now let's substitute. When we substitute there, y2 is going to be minus 2 and then minus 3, all divided by minus 3 minus into -1, like that. I'm having the brackets because of the negative thing. And from there we simplify. So the simplification of this is going to be minus 5 all divided by -3 plus 1 is -2, which is 5 over 2. Is that question clear to everybody of how we calculated the gradient of this line here?
Yes.
All right. So then from there, after getting that gradient, we then have to substitute it here in order to obtain the alpha. So it means tan of 180 degrees minus alpha will be equal to 5 over 2, of which after having that, you will then have to use arctan. So we're going to have 180 degrees minus alpha is equal to arctan 5 over 2. What is arctan 5 over 2? If you use your calculator there, what is arctan 5 over 2?
It gives me 68.19.
So it's 68 degrees 0.19. And then we take this 180 to the other side, and then we divide both sides by negative. Can you tell me the final answer we're going to get for alpha, which is that bigger angle we want to get here? The alpha. Can you tell me what is the value of alpha we're going to get after having that equation down there? Alpha will be equal to
111,81.
and that is expected because this angle alpha, it must be bigger than this other angle down here. So that is expected. So we are now having an answer of alpha. Let's go to the next question. So the next question is about a parallelogram. So it says, if ABC is a parallelogram, determine the coordinate of D. I believe you remember this question. We have covered something similar. So if we are now given that we have a parallelogram like this, then now we need to calculate angle D. If you still remember what we have done yesterday, can you tell me how did we get to the answer of coordinate of D? What did we do?
We first find the midpoint of BC.
Yes. And
Then
then,
we find the midpoint of AD.
yes.
And then we equate the coordinates of the midpoint of BC to the coordinates of midpoint of AD.
Yes. And
And
then
then we
after,
get the answer.
yes. There's another step which I want to hear from you after equating at the midpoint of BC and AD. What do we do after?
We equate the x coordinate to the x coordinate of the other midpoint, and then the y with the y.
Yes, yes. That's very, very important. So we're going to equate the components. The component x, and we equate to each other, and then the component y we equate to each other. So, but you will convince me really if you are able to do that by yourself. Can I give you 3 minutes to find this coordinate of D? I don't want to repeat it because it's something we have done yesterday. So quickly do it by yourself, and then when you're done, you send to me so that I can see if indeed you can be able to get the correct answer for this. And our expectation is that the value of D, the X value for D, it must be positive, and the negative, the Y value for D, it must be negative because it's on the fourth quadrant there. So please try to do that, and then when you're done, you send to me. I'm giving you between 3 to 5 minutes to do that question. It's your turn now. Patu, are you done? Patu, are you done? All right.
Yes.
Wonderful. You arrived to the same answer. D is given is having a coordinate of 2 is to -4. And that was expected. So X must have a positive value, Y must have a negative value because it's on the fourth quadrant there. So that is correct. So let's go to the next question, which is about proving. We need to prove that A is equal to 90 degrees. It's question number D. We want to prove that A is equal to 90 degrees. All right. There are several ways in which we can prove that theorem. So another simple approach where we can prove this is by finding the distance here and the distance there. And then after finding the distance, we then use tan in order to find if indeed the angle here is going to be 90 degrees. And then the second approach we can use is by determining the, all right, let me see. Yeah, in this case, let's use just that approach because we're not given any other angle. So if we're given other angles, we're going to use the approach of the angle. Now we are just supposed to use the approach of getting the sides. Already we have a distance of AB. Now let's find distance AC. So I'll do it with you on the board. Yes.
What about if we use gradients?
Oh, yes, you are right. Even the gradients, they can work in this case. Wherein, so the gradient of this line, the gradient of AB, when you multiply with the gradient of AC, it must be equal to -1, only if AB is perpendicular to AC. And if AB is perpendicular to AB, AC is perpendicular to AB, that will mean the angle A is equal to 90 degrees. So that is another approach you can use in this case. So, but let me use the first approach of the distance formula because I think it is the direct one where we will reach exactly to the angle that we are looking for, the angle A, right? So, Patu, even that second approach, we can use it. It's fine, eh?
Yes.
Yeah. So then now, let's use this, and then that will be equal to root of, let's substitute coordinate of A and C into that formula. So it means we're going to have -2. Okay, let me start with for X, we have -3 minus into -1 squared plus into -2 minus 3 squared. Can you put this into your calculator and tell me what you obtain? So for sure, this is -2 squared, which is 4 plus 25, and that is root. That will be a root of 29. Just quickly prove this for me before we go any further. Yes.
It's the square
So,
root of 29.
are you getting the same thing?
Yes.
All right. So after having that, then we can continue and say tan of angle A must be equal to AB divided by AC. Then we're going to have tan of A, which is equal to AB is root of 41 divided by root of 29. So then now we can obtain A by having the arc of root of 41 divided by root of 29. So can you put this into your calculator and tell me what we are going to get for that question? So what is arctan? Argument root of 41 divided by root of 29.
Sir,
Yes.
I get 49,9394. That's my answer for angle A.
All right. Yeah, and that it does not justify that this is A is equal to 90 degree. Okay. So in that case, we are left with no option other than to use the approach that Patu suggested, just to validate if because is this for showing or proving? Okay, we're proving. So let's use approach which is suggested by a Patu and see if indeed we can able to justify that A is equal to 90 here. So gradient of AB will be equal to y2 minus y1 divided by x2 minus x1. So then we substitute the value of A and B. We're going to have 1 minus 3 divided by 4 minus into negative 1. That will be equal to 2 over 5. We already calculated this and we get 2 over 5. And then let's also calculate the gradient of AC. So the gradient of AC, we use the same formula. So, but in this case, we substitute the coordinate A and C. So it means we're going to have 2, negative 2.
We have already calculated that.
We calculated this, and what did we obtain?
Yeah.
5 over
5 over 2.
Positive 5 over 2.
Yes.
And then, sir,
Yes.
for the gradient of AB, I got negative 2 over, okay, never mind.
Yeah. You are very right. It must be negative because it's 1 minus 3, right? Then let's multiply these two. So the multiplication of these two must be equal to negative 1. If not, then we are in a big problem. So gradient of AB multiplied by gradient of AC will be equal to negative 2 over 5 multiplied by 5 over 2, and that is equal to negative 1. Therefore, that confirms that A is equal to 90 degrees. So the second approach of part 2 works perfectly in order to justify this. Otherwise, mine is not working in this case of taking the distance this side and the distance that side. It's not arriving to the answer we were expecting to get. Therefore, stick with this approach from part 2, wherein you calculate the gradient and then you multiply them together, they must give you negative 1. So I believe we are together on that one, right?
Yes.
All right. Let me check. Can you be able to see from your side how many minutes is left for this meeting to close?
No.
I can't see from this side. Can you see the time? Remaining time?
No.
Where do we go?
It must show you without clicking anywhere. All right, I can see.
I know.
Okay, no, it's okay. We are left with 1 minute 36 seconds. So when it logs off, then make sure you log in again so that we continue. But with this 1 minute, um, I would like to read the next question we want to answer, which is about, it say, what type of parallelogram can ABDC be? So what type of parallelogram can this triangle AB, A, B, DC, what type of parallelogram is that? So we have two types of parallelogram. So the first one is the square, and then the second one is the rectangle. Oh, and then the third one, I think, is the rhombus. So now we want to identify the type of parallelogram that we are dealing with in this case. So so now that one, because